Our next section is about congruent angles and angle bisectors. And so just like segments, congruent angles are angles with equal measure. So if I look at my two angles drawn below, if I said that this angle right here was 60 degrees, then I would know this angle is also 60 degrees. And when you have congruent angles, you want to mark them similar to segments so that we know that they're alike. So if I were to draw two angle markers inside this angle, I would draw two on the others, so I would know that they are the same. And when I write that this angle is congruent to this angle, I have angle ABC. That vertex is in the middle is congruent to angle DEF. Okay? So then when we have a bisector of an angle, just like a bisector of a segment, a bisector is a ray that divides the angle into two congruent angles. So if we knew that, if we put some points on here, A, B, C, D, if we knew this was 32 degrees, we'll mark it with two angles, and this is 32. So since the measure of angle ABD is congruent to the measure of angle DBC, then we would know that our ray BD is a bisector. Of angle ABC. This ray right here is cutting our large angle into two equal pieces. In our first example, number 1, it says that BD is a bisector of ABC. And in the print-off on your note sheet, it might not look like a bisector. I fixed mine so that it looked a little more equal. But if it says it is a bisector, even though it might not look like it, if it says it is, that's the information you go with. So if BD is a bisector of ABC and ABD is 23 degrees, ABD is 23 degrees. We want to find the measure of angle DBC and ABC. Well, if DB is our bisector, it's cutting our big angle in half, so that means this half must be 23 degrees as well. Then if I know both of those pieces, if I'm looking for my whole angle, angle ABC, I'm going to add those two together, 23 plus 23. Gives me 46. So that is ABC. Okay, let's look at number 2. Number 2 says that YW is a bisector of XYZ. So we know YW here is cutting this in half. This piece is going to be the same as this piece. Okay, then the measure of XYZ is 2x plus 5. So I'm going to write that in there. And then WYZ, right here, WYZ is equal to x plus 30. Well, if I know that those two pieces have to be the same, I can set up an equation using 2x plus 5 and setting it equal to x plus 30. Now if I get my x's on the same side, get x plus 5 equals 30. Move my numbers to the other side. I get x equals 25. So then, with that information, if I'm looking for x, y, w, this piece right here is 2x plus 5. If x is 25, I'm going to have 2 times 25 plus 5. So I get 50 plus 5 is 55. So then for w, y, z, I know that piece is x plus 30. If x is 25, I get 25 plus 30 equals 55. And so I could have just plugged in that, or just known it was 55, knowing that these two pieces are equal. But this is a good way to check that I got the right answer. I know that those two should be the same. Okay? Our last piece, x, y, z, is my whole big angle, x, y, z. Well, if both of those are 55, I can add those together, 55 plus 55, and I get 110. Okay, we got one more piece we're going to look at, and this theorem says that each point on the bisector of an angle is equidistant from the sides of the angle. So that is telling me that if I label these points here on the graph, let's label them P and D. If I look at my point P here, if I were to measure from P to my ray BA, and here this piece, distance is always measured using perpendicular segments. So this means if I drew a segment perpendicular to that ray, perpendicular means I have 90 degrees, then I also draw one perpendicular to this ray, this segment is going to be the same. That's all this is saying. Those two pieces are going to be the same. Same on this side. If I drew a segment perpendicular, so I gotta extend this out a little bit. Again, perpendicular. This segment would be the same as this segment. So my point D is the same distance from BA as it is to BC. That's what our last theorem is telling us.